Hello and welcome to another one of D's ADD videos. Today we're going to be looking at this alkyl halide, ethyl bromide, placed in an alcohol solution. Here we have an alcohol solution. Anytime it's alcohol or water, it's a weak or moderate attacker, and it's going to be a one reaction. It's a solvolysis. It's two steps. It's one because it's unimolecular, because the kinetics of the reaction only depends on the ethyl bromide. The solvent is so much higher in concentration, it's irrelevant. It all depends on this. So if you remember one reactions, all of them occur in two steps. The first step, the leaving group goes away and the carbocation is formed. When the leaving group leaves, remember the polar protic solvent is best to stabilize the ion and aid in the solubility of the ion. It solvates the leaving group, stabilizes it, and then the protic part. And then the polar part helps in the solubility. After the carbocations formed, you can get some rearrangement occurring, but if there is no rearrangement, if you don't increase the carbocation stability, remember resonance 3,2,1 methyl for this, then it undergoes substitution or elimination. Typically, you can use silver nitrate to get it to substitution, and heat can typically move it towards elimination. It's kind of tricky. It all depends on the conditions. Step one, if you remember, was the carbocation formation. So we start out with our alkyl halide and alcohol. Here's our leaving group left, and here we have our carbocation that remains. It's just the CH2, the carbon that had the bromine attached to it, and now is positively charged. It's got an MTP orbital. If you do your formal charge for this carbon, you'll see that it is 4 minus the 1, 2, then the carbon would be 3 bonds, and 0 lone pairs would be +1 charge. So this is a heterolytic cleavage, if you remember that term. Bromine got the electrons from that bond, carbon did not. Created ions. At this point, we have to try to do our rearrangements if possible. So we can either shift a methyl group or hydrogen. But in this case, it's not going to do any difference. If I were to move a hydrogen, you just have the plus on this carbon, but it'd still be the same structure. All right, so then after that, you can either undergo substitution or elimination. That's why one reactions typically aren't good for synthesis. You'll get too many rearranged products, too many unwanted elimination products, or substitution, depending on which one you're trying to get. But let's just focus on what would happen with the elimination portion of this reaction. We will also look at the substitution in the beginner substitution SN1 video. But here what happens is that instead of the nucleophilic attack that we would see in a substitution, the methanol abstracts a hydrogen from the adjacent carbon. So let's see what that looks like. Here's the methanol. Here are the lone pair electrons on the oxygen. It's going to come and abstract one of the adjacent hydrogens, doesn't matter which one. And then the electrons get left behind, takes the hydrogen away, and you get a double bond. The bonding electrons from here go into the MTP orbital here, and then you get a pi bond formed. So then what happens? Well, you get this alkene and the protonated methanol. Sometimes you'll have more than one possible alkene product. In that scenario, you're going to use Zatsev's rule. And basically, it says that the more of these hydrogens we have replaced as methyl groups, the more stable it will be, or any group. The more substituted it is on either side of alkene, the more stable it is. And that's pretty much it for an E1 reaction. Again, form the carbocation. Once that's formed, the solvolysis reaction continues where the solvent does all the work, comes, abstracts the hydrogen, leaves electrons, forms alkene. And we'll probably do one with the Zatsev's in the intermediate. So check out the intermediate and advanced videos as well. I'll do a hydride shift in one and a methyl shift in the other, so you can see what those would look like. As always, you can watch all the videos in the world, go to all the tutoring sessions in the world, but it's not going to help as much as sitting down and just doing problems. So practice, practice, practice. Thanks for watching and have a great day.